Okay, we'll have a look at example 4. Vessel's length 137.5. We're going to pass under a bridge with a minimum clearance of 0.4 and the height of the bridge above the waterline is 21.67. We're given our present drafts, but let's leave those for now. That's not the important part at the moment. Foremast is 109 metres forward of the after perpendicular and is 26.77, and the aftermast is 35 metres forward and extends 27.03. So I've done the sketch here. Length between perpendiculars 137.5. We're told that the aftmast is 35 metres forward of the after perpendicular, 35 metres, and extends 27.03. The forward mast is 109 metres forward of the after perpendicular and extends 26.77. So between 35 and 109 is this distance here of 74. And if that's 137.5 and that's 109, this distance must be 28.5. So we can always work out these three distances: 35, 74, 28.5. We can always also work out this difference if we can get the work out the drafts forward and aft. So the draft at the foremast is going to be the height of the bridge above water, 21.67. This of course is the draft that we require, 21.67 minus the 26.77 plus the 0.4 clearance. So it gives us a foremast draft of 5.5. At the main mast, again, height of bridge 21.67 minus the 27.03 plus 0.4, 5.76. So at the masts, the drafts have to be 5.5 and 5.76. So we write here aft peak, main mast, foremast, forepeak, the four distances, difference between them 35, 74, 28.5. So we know all those three. We're trying to find the two drafts here. We know these two drafts, we just work them out, 5.76 and 5.5. Difference between them 0.26. So we can say these triangles are all similar. 0.26 over 74, y over 35, x over 28.5. So x over 28.5 equals 0.26 over 74 for the forward difference, and for the aft difference it's y over 35 equals again 0.6 over 74. We cross multiply out and we find the forward difference is 0.123, aft is 0.1. You'll find with these the best way is just to do 2 or 3 practice ones, and then it'll become second nature to know which values to put there with the similar triangles. Once we've got these differences, we can apply them to the mast drafts that we worked out, subtract the forward one, add the after one, and we can find our final drafts at the perpendiculars now: 5.4 forward, 5.883 aft. So we've got 5.4 forward, 5.883 aft, and we know our initial drafts are 4.31 and 5.21. So what we need to do now is find the final true mean draft, and obviously the displacement from the tables. Usual thing, add them together to get the average mean draft, get the longitudinal centre of flotation, work out the true mean draft. So we find that our final true mean draft is 5.642. We also find our initial true mean draft, 4.756, the same procedure, and therefore if we can get the displacements at these values, we simply subtract one from the other, and here we have our displacement 5.642 is 11496 and our displacement at 4.756 9542. Subtract one from the other, ballast to load 1954 in order to lower the vessel to go under the bridge. So you can see we only look at the initial forward and after drafts. They only come into play right at the end. We only use those to work out our initial displacement. We don't use them for anything else. The important values are the foremast values. These enable us to calculate the difference to apply to the drafts at the masts to give us the drafts at the forepeak and the after peak, because of the similar triangles as you saw in the sketch.